Today's show is brought to you by ExpressVPN. Protect your online activity today and find out how you can get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Visit tryexpressvpn.com/space to learn more.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hello once again. Thank you for joining us. This is the podcast we like to call Space Nuts. My name is Andrew Dunkley, and joining me as always is astronomer at large Fred Watson. Hello, Fred.
Hi, Andrew. Good to be with the Space Nuts again.
Yes, indeed, and thanks to all our nutty friends who keep listening in for reasons we cannot possibly fathom. But we do appreciate it. Now, today, Fred, we're going to talk about the big news this week, and that is the landing of InSight on the planet Mars. And by all reports, everything went swimmingly, which is great because there's no water on Mars. But they landed and they're happy, and now it can get on with the business of finding out what's going on inside. We're also going to look at a comet that will be literally visible to the naked eye in the next few weeks, and we're going to find out about another exoplanet. And Elon Musk is nutty as a fruitcake. He's changing the name of his BFR spacecraft to something pretty lame, from what I can understand, but we'll find out more about that later. But first, the big news of the week. InSight is on the surface of Mars, landed safely. Those 6.5 minutes of trepidation turned out to be nothing to worry about. It's all good.
Well, that's right. It's only nothing to worry about because people did such careful work beforehand to get the spacecraft hitting the Martian atmosphere at exactly the right angle, 11 degrees, I believe it was, and at the right speed, of course, something approaching 6 kilometers per second. Yeah, so 6.5 minutes to slow down from 6 kilometers per second to zero. It landed perfectly. We got an immediate image, actually, back from the surface of Mars, seen through the rather dusty lens cap, because when a spacecraft like InSight lands, because it uses rocket motors to stop its final descent and drop it down neatly onto the surface, it kicks up a lot of dust. And in fact, I think that's where we are at now in the process. We're waiting for all the dust to settle. It takes a few days for that to happen.
Yeah, it's the same as where I live, actually.
Would be.
We had a massive dust storm last week.
When you arrive with your rocket motors blasting, you kick up a lot of dust. Yeah. It sounds a lot like Space Nuts does that. The big weight, though, it comes because what the mission scientists want to do is take a very good look at the place where InSight has landed, because they've got this sort of hinged arm that can deploy the seismometer on the surface, which is one of the main reasons why InSight has gone there. A seismometer to listen for Mars quakes, to tell us more about the interior of Mars. That has to be deployed in the right place. You don't want it kind of tilted up on a stone or something like that, where it just won't pick up vibrations from the ground. So they'll do a very careful survey, which will take, I think, about 2 months, and then deploy the seismometer, and then we'll start listening for Mars quakes.
And do you think they'll actually detect Mars quakes? Is there any evidence at the moment that they do have them?
Well, the things that would cause the thing about Mars is, as far as we know, it doesn't have plate tectonics. So it doesn't have, crustal plates sliding under one another and tearing apart and all the kinds of things that happen here on Earth, which predominantly cause earthquakes. So that's a phenomenon that doesn't happen. And it's one of the reasons why people want to know what's going on there, because, the two planets are relatively similar, but Mars has just one crustal plate. So what you would expect to find is, first of all, meteorite impacts. That would cause vibrations that would be picked up by this seismometer. It's sufficiently sensitive to do that. And also perhaps even vibrations in the crust caused by shrinkage of the crust over very long periods of time. But that too could cause Mars quakes. So all of these sorts of things, plus convection in the mantle of Mars, the plastic layer underneath the crust. That's all the kind of thing that will be listened for. And I think they're pretty confident of hearing stuff. I mean, there is a precedent here, Andrew, because the seismometers left behind by the Apollo astronauts on the moon picked up enough stuff that we now have a much better idea of the internal structure of the moon than we had before. So it's not the first time this kind of thing's been done. The other experiment that's being deployed is the temperature gradient experiment, where a little mole will dig down into the surface of Mars and carry with it heat sensors. So we might detect something about the amount of heat flow coming from the planet's interior. It's not going to go very far down. I think 5 meters is the maximum that people are expecting it to go. That's quite a long way, though.
Holy moly.
Yeah, oh, quite so, yes. Well done. Well done, old chap. Trust you to get one like that.
Yeah, I know.
The bottom line is that nothing's gone down the hole. Everything is going well. InSight seems to be on track to be a very successful mission, and we look forward to 2 years of data taking once they've got the seismometer established.
First and foremost, though, they've got to successfully remove the lens cap, because there's been some dramatic lens cap failures over the years. I think was it a Russian probe that landed on Venus and it melted to the camera? Or something to that effect?
Yeah, it was one of the Venera probes that the Soviet Union sent to Venus. Well, the good news is that lens cap's already gone.
Oh, good. All right. Well, that's the biggest problem solved.
Yeah.
There'll be more from InSight, I'm sure. There's a lot of data to come, and we'll be very excited to see what they learn, and we'll certainly tell you about it here on Space Nuts. Now, Fred, we're moving straight on to our second topic, and that is of a comet called Virtanen. And the reason we're talking about that is because it's almost upon us. Not literally, but it will be visible in the night's sky, we hope.
Yes, that's right. It will indeed be visible in the night sky. It's a comet that the person who discovered it, despite having a Norwegian or Scandinavian sounding name, was actually American, so it's probably Virtanen
okay.
with a W, who was at the Lick Observatory when he discovered this comet back in 1948. It's what we call a short period comet with an orbital period of about 6.7 years, and from time to time, it passes close to Jupiter, which kind of disturbs the orbit. So its orbital period changes slightly. It's very interesting the way these things evolve because of the gravity of the giant planet Jupiter. But this year, we've got a really good chance of seeing it in the night sky as it progresses southwards. It's closest to the Earth on, I think, December the 15th and 16th, when it will attain what we call a third magnitude, which means well within the naked eye visibility. The only problem is it will be rather a full moon at that time. And the comet itself has got a very diffuse coma. The coma is basically the nebulous region around the comet caused by the gas, the ices on the comet outgassing and turning into a plasma. So it's diffuse. It means it's not a well-defined, sharply defined object. It is going to be, I think, quite difficult, but with binoculars, it should be easy to see this sort of fuzzy patch. There will be plenty of places on the web to check for Space Nuts listeners to check exactly where it will appear in their skies. But it's looking good. There's some very nice images already of Virtanen taken by people with normal small-sized telescopes.
And it's green, which is...
Yeah, the green is, I think that comes from carbon monoxide emission, if I remember rightly.
So it's a pretty dirty comet.
All comets are dirty.
Yeah.
That's what they are, balls of dirt held together by ice.
Okay, so that's one to keep an eye out for, and it'll be closest to Earth since 1950, and that'll happen on December 15 and 16. And I'm guessing because of our orbital properties and its movement, most people will be able to see it. Yes,
I think that's right. I think it's it's in the northern sky when it's at its closest, but it's sufficiently far south that we should see it in the south too.
Okay. Something to keep an eye out for, and you can put that one in your diary, and you don't have to wait a couple of billion years like most of the stuff we talk about. So keep an eye out for Comet Witanen on December 15, 16. If you've got the gear, you'll be able to see it sooner, if not already, and for a lot longer. This is Space Nuts. Andrew Dunkley here with Fred Watson. Now, let's take a little break and find out more about our sponsor, ExpressVPN, rated #1 by TechRadar. This is the one I use. I've been using it for a couple of years and I love it. When I joined ExpressVPN, they were brand new to the market, but I read a lot of reviews and did a lot of comparisons. And there was just something about their business model that I particularly liked. And a couple of years down the track, honestly, can't complain. Their interface is very easy to use. Their service is second to none. I've had to contact them a couple of times about certain things that I wanted to do, and they were brilliant. So you may be wondering why I do need a VPN at all. It's all about privacy. Do you really want big tech companies, governments and others knowing what's going on with your online activity? Even if you're having nothing to hide, it just feels downright creepy. I think you'll agree. And governments are getting more and more interested in what you're doing every day. And so, yeah, protecting your privacy is what VPN is all about. And how often do you run across websites that you want to get information from only to find that they're geo-blocked? This is becoming an increasing problem, but ExpressVPN solves that problem for you. Now, if you go to our special URL, you'll see quite a list of things this service can help you with, things you may never have thought of before. As I say, it's the one I use, secure, fast, and it just works. So protect yourself online today and find out more about how to get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Try expressvpn.com/space to learn more, and you'll find the link details in the show notes and on our website. Now, back to the show.
0G, and I feel fine.
Space Nuts.
Now, Fred, we're going to focus our attention on an exoplanet, HR 8799c, and it's making the news because they think they've been able to learn a fair bit about this one, and that's what, it's one thing to discover exoplanets, it's another thing to really, get down and dirty and find out what's going on the surface or below. So this could be exciting.
It is. It's very much a pointer to the future, is this story, Andrew, because this is a solar system that we already know about. It was discovered, I think, quite a few years ago, and it's one of the very few planetary systems or exoplanetary systems, in other words, planetary systems around other stars. It's one of the very few that we can image the planets directly. Most, of course, as we've discussed many times, most of these planetary systems that we know about are not directly observed. What we see is either the dimming of the light of the star as its planets pass in front of it, or we see the wobble of the star's motion as the planets pull it one way and another as they go around in their orbits. So those two methods have been very successful in discovering planets of other stars. But just one or two of these planetary systems are capable of being imaged by ground-based large telescopes, partly because they're face on, if you see what I mean. Their solar systems are, the plane of the solar system for these stars is at right angles to our line of sight. So what we see is the star in the middle and the planets going round. It's just like a plan view of the solar system. Yeah. In fact, this particular one, it's around a star which rejoices in the name of HR 8799, and as you've said, the planet we're talking about is C, which is 8799c. But HR 8799 was the first star with planets to have them directly imaged from Earth.
Okay.
Back in actually 10 years ago, which is quite extraordinary that we've been doing this for so long. But what's happened now at the Keck Observatory, which has its telescopes in Hawaii on Mauna Kea, on the big island of Hawaii. You've been there, I've been there.
Yep.
It's a great place. They've used a new instrument at the Keck Observatory, which uses something called adaptive optics. And adaptive optics essentially compensates for the blurring effect of the Earth's atmosphere. It's why we're going ahead and building ground-based telescopes with mirrors 20 or 30 meters in diameter, because it's only worthwhile doing that if you can get rid of the blurring effects of the atmosphere. And you can do this with this technology of adaptive optics. It's quite fascinating stuff. You fire a laser up into the sky where it's of a particular color, the laser, which excites luminance in a layer of sodium, which is at about 90 kilometers from the Earth's surface. That layer of sodium comes from entering meteorites or meteors. That's where it comes from. And that basically forms artificial stars, which you can then lock onto and correct for the turbulence of the Earth's atmosphere. It's great stuff. So what that means is you can see very fine detail, and that's clearly what you need when you're looking for planets close into a star that's rather a long way away. I'm trying to find the distance of this star because I can't remember what it is. It's certainly in the solar neighborhood, but I can't find a figure at the moment. I'm sure we'll check up on that. Somebody'll phone in and tell us.
They will. We're waiting for the call right now.
Yeah. All right, 129 light years. There you are. Got it.
It was in the small print, wasn't it?
Yeah, the small print, the fine print. That's where it always is. 129 light years away, as the crow flies, is this planetary system. So it's a good way off. And to see planets orbiting a star at that distance, you need to be able to penetrate very fine detail. But also, you've got to have a way of blocking out the light of the star itself, which is much brighter than the light of its planets. And that is what the particular instrument that we're talking about does. In addition to that, though, once you've got the adaptive optics system working and got rid of the light of the star, you can then analyze the light of the planets with a spectrometer, the device that forms the rainbow spectrum of these objects and looks for the barcode of information in it. And so astronomers have done that, in particular with this object HR 8799c. It's a gas giant planet. It is round about 7 times the mass of Jupiter. Its year is 200 of our years.
Wow.
So that tells you it's quite a long way from the parent star, because it's got such a long orbital period. And that, of course, is one reason why you can carefully analyze the light from it without getting interference from the star.
That's massive, that planet. 7 times the mass of Jupiter.
Yeah, it's a big one. It's definitely a big one. If it was twice that size, it would count as a brown dwarf star.
Yeah.
Because brown dwarfs, when you get bigger than 13 times the mass of Jupiter, you get something called deuterium burning, which is a low-level nuclear process, and that produces what effectively is a halfway between a planet and a star. But this is not that level. This is definitely.
Would it be fair to say that gas giants, maybe not all of them, but some of them are failed stars? Or
yeah, there's sometimes. I mean, Jupiter is sometimes referred to as a failed star. It would have to be, as I said, 13 times more massive than it is for this process to be taking place. But it didn't quite get enough gas around it when it was forming to get up to that mass. So it's a planet rather than a star. So the bottom line in this story is that what was found was the existence of water in the planet's atmosphere, and also a lack of methane. Methane, I think, is fairly prevalent in Jupiter's atmosphere, but there is no methane detected in the atmosphere of HR 8799c, which I'm sure excites the planetary scientists, because they can then deduce what interesting stuff has been happening on that planet throughout its life.
It also proves that nobody's up there herding cattle.
Quite so. There are almost certainly no cattle on on HR 8799C.
Oh dear. Now, what do we know about the star that it's orbiting? Is it a stock standard star, or is it bigger, or is it
My
dwarf?
recollection is that it is that it's basically a red dwarf star. It's not a kind of a sun-sized star. I think it is a dwarf star, and the reason I'm saying that is that it's got an HR designation, which I think tells you that it is an unusual object. It's a young star actually, and has quite a lot of dust around it, which means it's still in its relative infancy. And the suggestion is that this gas giant that we're observing is a particularly young gas giant as well.
And being HR 8799C suggests that this is not the only planet.
There are, in fact, A and B, and indeed D as well. So there you are.
And the good news is it's visible. We can photograph it. So and I've seen a couple of those photos. So I mean, all you see in terms of the planet is a dot, but you do get the visibility of it. So
yes, that's right.
Instead of an artist's impressions are great, but when you can see the real thing, it's even more exciting. So
it's even more exciting, absolutely.
Well, it's good that we can learn a bit more about what is in the scheme of things, a nearby neighbour, universally speaking. So, and I'm sure they'll be studying it even more to find out all the secrets.
That's right. So the unfinished business here is that this points the way very much towards what we might do with the 30-metre class telescopes. In fact, the Keck Observatory is very closely involved with the TMT, which is the 30-metre telescope. University of California and all the rest of them that contribute to that, Caltech. The 30-metre will have similar instrumentation, but because you're gathering so much more light and you're seeing so much more detail, then you can start looking at much more subtle signatures in the atmospheres of planets, including biosignatures. Yes. Tells you there might be life there.
That's what we're looking for. Yeah. I'm still shaking my head about TMT. Anyway, we'll certainly let you know if there's any changes or discoveries regarding that planet and maybe some others as the technology improves. You're listening to Space Nuts. Andrew Dunkley and Fred Watson, of course.
Okay, we checked all 4 systems and keying with a go.
Space Nuts.
Now, Fred, to Elon Musk. He's certainly achieved probably more mentions on this podcast than anyone else that I recall, perhaps. But that's because he's always in the news and he's always got something interesting to say or do. Although this one, this one might be a little bit of a head-scratcher. He wants to rename his BFR, the Big Falcon rocket.
That's right. So this is just to set the scene. This is it's a spacecraft that will carry people. It's distinct from the rocket booster that will send it up into space, which is now called the Super Heavy, because it is capable of sending very large loads into space. It doesn't exist yet, but it will be built. Mm-hmm. So originally, the plan for this spacecraft, the passenger-carrying spacecraft, it was originally called the MCT, which was the Mars Colonial Transporter. And then Elon didn't like that, so he renamed it the ITS, which is the Interplanetary Transport System. And then it became, probably, I guess a year or so ago, maybe 2 years ago, it became the BFR. And that stands for, well, you've got to listen carefully to this. It stands for the Big Falcon rocket.
Yes, it does.
Because Falcon is the name of the rocket sequence that, or the series of rockets that Elon has developed. Falcon 9, I think, is the current one, but the BFR was the Big Falcon rocket. But he's decided he doesn't like that.
And apologies to all the Irish, because with an Irish accent, that means something completely different.
I think it probably does, yes. It's now we should probably apologise to everybody, because it could mean something.
It could mean anything.
But it's now called Starship.
No.
Starship is a lot easier to say.
Really? Is that what he came up with? Starship.
Yeah.
That was already taken by a band. I mean,
yeah, indeed, that's right. Yes. So Starship is the new version. He has been. We haven't seen what it looks like yet, but Elon has given us a tempter with a tweet that said that the new version is very exciting and delightfully counterintuitive. Now, a lot of what Elon does is counterintuitive. Who would have thought of bringing rocket boosters back to Earth or making electric cars? So I think it could be quite interesting to see what the Starship looks like and what it sounds like.
Yes, indeed. But you know, if Elon Musk is attached to it, it will happen. He does seem to put his money where his mouth is. Sometimes he puts his mouth in the wrong direction and gets himself into trouble in the news. That's been the case of late a couple of times. But he gets on with the business of making these things happen, and I think that's really exciting. And now that the space race has sort of gone commercial, it will gain pace, I imagine. We're going to see a lot more development over a shorter period of time, with so many more governments involved as well. It's a very exciting time in terms of space travel and tourist opportunities.
Well, that's right, as well as the commercial aspects of it all. So Elon, I think you and I have spoken about this before. He has a plan to send a friend of his on a trip around the moon in 2023 with this with the Starship. I can remember BFR, but I can't remember Starship.
Yeah, it's very hard to remember.
Just too obvious. So this Japanese billionaire, you and I have spoken about him before, and I'm sure I've mispronounced his name before. I think it's Yusaku Maezawa. He is the first passenger who's basically going to be a paying customer on the Starship, with I believe a number of his colleagues. But the plan is to send the spacecraft along with its passengers around the backside of the moon, basically to do what Apollo 8 did exactly 50 years ago. Do you remember Christmas Eve 1968? You don't, but I do.
I do, actually.
Very exciting.
I was very young, but I do recall it.
Yeah,
vaguely.
I was very young too, compared with now. Apollo 8 going around the back of the moon and taking that marvelous, Earthrise picture that became so famous. That's what's called a free return trajectory. You basically send it on a path to the moon, but one that will be captured by the moon's gravity, but not to the extent that it will go into orbit around the moon. It just comes back again, more or less on the same path, and then makes re-entry and comes back to Earth, as happened with Apollo 8. So interesting times. That's 5 years away. Andrew, I hope Space Nuts is still going then, so we can talk about what happens to this very interesting and delightfully counterintuitive spacecraft when it goes around behind the moon.
I just think it's exciting that privateers can do now, or will soon do, what was a very difficult operation in the 60s.
Yeah, it was into big governments. That's
yes, exactly, and now it's private enterprise that's looking at doing these things while the governments do the other stuff that we often don't know about. Yeah. But and he's of course not the only one. There are a few ventures coming together to try and get tourists in space. I think it's interesting that he wants to send a friend. I mean, if you're going to do that, find your worst enemy, man, and send him.
Well, maybe we don't. Maybe that's it, but we don't know that.
We don't.
There's a conspiracy theory for you.
Yeah, well, we'll keep that under our hats. But we'll watch with interest. And as always, a lot of the stories we talk about have potential follow-up, because there's never any completion to astronomy. We always have something new to talk about, and when we talk about that, there's always something new to discover about that discovery.
Yes, indeed.
And so it goes on. Now, we didn't get to any questions this week, which was by design. We wanted to talk about a few things that were going on as we speak, but we certainly haven't shut the door on questions to Space Nuts, so please send them to us via Facebook. It seems to be the most preferred way, and it's the easiest way, and I know how to use Facebook, so I can find them. Sometimes it takes me a week or two, but I will get to them. And we do appreciate all your feedback and all your support of our little podcast. And Fred, as always, thank you so much. Nice talking to you again, and we'll catch up ultra soon.
Sounds great, Andrew. I look forward to it, and we'll keep our eye on the heavens and let everybody know what's happening.
Indeed. Fred Watson, an astronomer at large. And from me, Andrew Dunkley, your host, thanks again for listening to Space Nuts.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Subscribe to the full podcast on iTunes, Audio Boom and Stitcher, or your favourite podcast distributor.
This has been another quality podcast production from Bytes.com.